Hi, my name is Rick Edgman, and I'm your professor for Mgt602 Production and Operations Management. The topic of this particular lecture is inventory management, and there are many tools and techniques for inventory management. We're going to look primarily at one that is referred to as the economic order quantity. There are several others that are mentioned by name in this particular slide set. The entire slide set is only about 25 slides, but the only one of those techniques that we'll cover is economic order quantity, and for that reason, about 10 of the 25 slides are hidden. Therefore, this will be a very short lecture, and we'll just take our time. So what is inventory? It is that stuff that we're holding for sale. It's consumed in the production of goods and services. Lots of forms of inventory for manufacturing competition, at least. Raw materials, work in process, finished goods, stores, and extras, right, spares, those sorts of things. We have some objectives in management of inventory. That is, we want to minimize the investment that we have in inventory. And we want to meet the demand for products by efficiently organizing the production and sales operations. Okay, so where are we trying to make our money? On the actual production of things and on the sales of those things, but not just by having those things sit around inventory. So there are lots of costs for holding inventory. There are ordering costs, inventory carrying costs, so maybe you have to pay, let's say, insurance on that which you have in store. The opportunity cost of not being able to spend that money in other ways because you have it tied up in inventory, shortages, and so on. There are also some risk if you have a lot of inventory. So having a lot of inventory, generally speaking, equates to loss of flexibility or loss of agility. And it subjects the company to certain types of risk. One of which is that you have the stuff sitting around and all of a sudden you have a price decline, so it's not worth what it was. And you were paying holding costs that were more, maybe insurance costs that were higher because you were paying for it when it was valued more highly. Things that sit around deteriorate, so product deterioration. That is just the nature of things. They tend to trend toward increasing disorganization, not increasing organization. So they trend toward deterioration. And as it's sitting there, the reality of it is there are new product generations that are coming out or new products competing for the same space. So product obsolescence. Now those various tools and techniques of inventory management and control, a few of those are listed on this slide. Activity-based costing, order point problem, two-bin technique, VED, HML, SDE, FSM, order cycling systems, just-in-time. We've talked a little bit about just-in-time in prior segments because just-in-time is associated with lean approaches. So we have talked a little bit about just-in-time, and in fact we'll talk about it more later in the course. But in this slide set, we're going to focus on the economic order quantity, or EOQ. Each of the other techniques that you see listed on this slide are discussed briefly, typically one slide per technique, in hidden slides at the end of this particular slide set. So if we're going to focus on economic order quantity, it helps to know what we mean by that. The economic order quantity is the level of inventory at which the total cost of inventory is the smallest it's going to be. And when we say total cost of inventory, what we normally acknowledge is that there are two main sorts of cost associated with inventory. One is what's called ordering cost. The other is what's called carrying cost. So ordering cost plus carrying cost is equal to total cost. We want to minimize that total cost. This would be the typical sort of graph that you see to represent that. Now, the graph is not 100% accurate in the sense that the lines aren't all exactly what they should be and so on. But you see the two bottom white lines, the one that is just a slope going up and labeled carrying costs. There's one set of the cost. The other would be the ordering cost. The ordering cost you can trace with my cursor right here. Okay, so for the total cost curve, if you add, let's say, the coordinate for carrying cost plus the coordinate for ordering cost, this coordinate plus this coordinate should equal that height right there. And that would be true all along the curve if the curves are drawing completely accurately. But we're seeking a particular point. Now, again, this is not perfectly accurate. You can see that the minimum of this total cost curve is right around where the cursor is because the line is inaccurately drawn. And that's the only reason that it doesn't line up with this place right here where carrying cost line and the holding cost line, or excuse me, the ordering cost line intersect. So if you add where these two intersect, then the minimum total cost is actually twice whatever this coordinate is. So what is the economic order quantity? The economic order quantity is a measurement that we use a lot in things like operations, logistics, and supply chain. It is a tool that's used to determine the volume and the frequency of orders that we need to satisfy a given level of demand while minimizing the cost per order. So the volume, how many items are in our order, the frequency, how often do we have to order. What's the importance of EOQ? It is a set point designed to help companies minimize the cost of ordering and holding inventory. Cost of ordering inventory falls with an increase in order volume, usually due to what's called economy of scale. That is, or a quantity break. Sometimes it's called a quantity break. You get a quantity break for buying more. Or because what happens is that there's a set cost associated with placing the order itself. Maybe it costs you $1,000 every time you place an order. If you place a lot of orders, you're going to be spending that $1,000 a lot more times than you would be if you were placing larger orders but less frequently. So what is the EOQ formula? The EOQ formula, and that's what it will be. So ultimately what I'm telling you right here is that we need to be able to use a formula that delivers for us that number, which is the best number of items to order every time we order. So it's a formula that's calculated by minimizing the total cost. That is holding cost plus holding cost plus ordering cost. There's a formula for ordering cost plus holding cost. So the economic order quantity is represented by Q. What that means is that the formula that we have will involve Q, and you know from your calculus course that if you take the derivative of the formula with respect to Q, then you will identify one of three things. You'll identify either a minimum, a maximum, or a point of inflection. Now, in this particular case, it turns out to be a minimum. And that's what we're looking for. There are several things we need to know, and those several things are represented by these letters, D, Q, S, C, H, and lowercase I. D is the annual quantity demanded. So what's our annual demand? Maybe it's 2,000 items. Q, how many items are in the order every time we order? Well, if your demand were 2,000, you ordered 10 times a year, then Q would be 200 every time. S, what is your ordering cost, fixed cost? C, what is your unit cost? How much does it cost you per each unit that you order? H, what is your holding cost? And I, what's the interest rate or the carrying cost? So for the ordering cost, we need to determine the number of orders. That's easy. That's D divided by Q. D, demand, divided by Q, the quantity per order. And that would tell us how many orders annually that we need to place. Now your problem initially is that we'll know D, but we don't know Q. That's okay. We're going to get Q. Similarly, the annual ordering cost is the number of orders times S. Right? Do you remember what S is? Look back at the prior slide. So, times S. What about the holding cost? The holding cost is, it says this, that holding inventory comes with its own cost, and you've seen what some of those are. So there could be warehousing costs, there could be insurance costs, there could be all kinds of different costs. It could be that basically it's an opportunity cost, which is to say that you've got your money tied up in inventory when you could have been spending it on something else. Why do you have inventory? Just in case. Just in case what? Just in case you need it. Sometimes we call that wishful thinking. Okay, so there are holding costs. So what we've got is the holding cost per unit is usually expressed by H. And it's just the interest rate times the cost per unit. And we're going to illustrate all of this with an example. So if we have the assumption that demand is constant, and you know and I know that for many sorts of things, demand is not level. It isn't constant. You know, for example, that certain types of things, there is a big run on certain types of things from, let's say, Black Friday all the way through after New Year's sales. Okay, you know that. You might know that there is usually an annual spike in demand for things like sheets and pillowcases for your bed. And that's an annual white sale, and that usually comes around, let's say, Labor Day in America. So we can assume that demand is constant, and that may be reasonable for a number of things, but not so reasonable for other things. But nevertheless, to illustrate, we're going to have the assumption that demand is constant, so that the quality of stock can be seen as depleting at a constant rate over time. That's the graph that you see in the lower left-hand corner here. And when inventory reaches zero, an order is placed so that you replenish the inventory. Now, we should also say, by the way, that usually we don't let inventory reach zero before we place our order. Why? Because it takes time to deliver the order. But nevertheless, what we have is, what is the holding cost of inventory? The holding cost of inventory is calculated by finding the product of the inventory at any instant and holding the cost per unit constant. So that this is Q divided by 2 times H. And again, we still don't know what Q is, but we're going to be able to figure that out here in just a minute. And we're going to be able to figure it out because the total cost and then the formula for the economic order quantity Q are given right here. Remember that the annual inventory cost has two elements. It has this first piece, it has this first piece and the second. And then we have EOQ is the derivative of the total cost formula with respect to Q. And if you remember your calculus, then you would find that derivative to be square root of 2 times S times D divided by H. Let's see if we can determine what this looks like in an example. So suppose that we have a company, they have an annual demand, 2,000 units. Cost the company $1,000 for every order they place. That is just the cost of placing an order, plus $250 for each unit in that order. So if I ordered 4 units, it would be $1,000 plus 4 times 250, or $2,000 overall. Okay. So there's a carrying cost also faced by the company, which is 10% of the unit cost. So in other words, every unit that you obtained, while it is just sitting around, is costing you something. Let's suppose it's that 10% interest rate. So let's find out, what is the economic order quantity? Now you could determine this just by doing a lot of different calculations and getting at least close. What do I mean by that? I mean, you could try a lot of different quantities and run through the calculations. You could get the number of batches per year, number of orders per year. Excuse me. And then you would be able to determine the annual order cost. You would also be able to determine the annual holding cost. More orders means less holding cost. So if you were ordering 50 at a time, you'd have 40 orders at $1,000 an order, and so on. So $40,625 for your annual total cost. Okay, what if you were doing, say, 250? 250? Well, let's see. 2,000 is the annual demand, divided by 250 is 8 orders. That would cost you $1,000 per order as a fixed cost, $8,000. But then there would be the annual holding cost, which you could find to be $3,125. So a total annual inventory cost of $11,125. You could try other numbers as well. What you would find is that the best order quantity, if you wanted to minimize total cost, would be 400 items. That would be called the EOQ. Okay, so that's the EOQ. I guess we should see that for various order quantities, one of which happens to be 400, that you would see the smallest annual total cost. And you can see by examining this final column in the table that that's true. Now, that's by trial and error. We don't have to use trial and error. We can use the formula for EOQ. Let's do that. So here's what we've been able to identify. We know what the demand is. The demand is 2,000. We know what it costs us to place an order every time we place an order. We know what the unit cost is. The unit cost is, here we go again. The unit cost is $250. The holding cost is I as a decimal, I times C, or 10%, 0.10 times 250, $25. So let's see. We know what the total number of orders we have per year are. It happens to be demand divided by Q. So that's going to be 2,000 divided by Q. We'll figure out how many that is in a minute. What's your annual ordering cost? D divided by Q times S. That'll be 2,000 divided by Q times 1,000. We know what the holding cost is per item, $25. And we have the formula for the annual total cost. It is D divided by Q times S, which is the annual ordering cost, plus Q over 2 times H, which is the ordering cost. And EOQ would be the derivative of the total cost with respect to Q. We found that that is the square root of 2 times S times D divided by H. And we know every one of those. So 2 times S, S is 1,000, times D, D is 2,000. 2 times 1,000 is 2,000, times D, which is another 2,000, is 4 million. Divided by H, that's 25. That gives us 160,000 under the radical. The square root of 160,000 is 400. So there's your economic order quantity. And that would say that you would need to order D divided by Q, 2,000 divided by 400, 5 times annually. And it would give you the annual ordering cost, the holding cost, and all these other things. So you should be able to, for an exam or an assignment in this course, if I gave you similar sorts of information, you should be able to populate this table or a similar table. You should be able to find the economic order quantity and then things like the number of orders annually and so on. And that is all we have for today. Thank you.